In section 1.4, we introduce trigonometric identities. Identities are statements that are always true for values of the variable for which the functions are defined. So this is the complete list of identities we're going to look at in this section, but we're going to take these in groups. Let's go ahead and take a look at the first group. The first group of identities are called the reciprocal identities. And they are called the reciprocal identities because, as you can see in the first one here, it says the cosecant is equal to 1 divided by the sine function. Now, when you take 1 and you divide it by something, that is what we call the reciprocal of that thing. So we're saying cosecant is the reciprocal of sine. Likewise, sine is the reciprocal of cosecant. Now, why is that exactly? Well, let's remember that sine of theta is defined to be y divided by r, and cosecant of theta is defined to be r divided by y. And so you can see that these expressions are reciprocals of each other. So y divided by r can be thought of as 1 divided by r over y, and r over y can be thought of as 1 divided by y over r. And this is just because of the basic rules for dividing fractions. So it is for this reason that all of these that you see here are reciprocal identities. So secant is the reciprocal of cosine, cosine is the reciprocal of secant, cotangent is the reciprocal of tangent, and tangent is the reciprocal of cotangent. Let's take a look at a couple of examples. So in this first example here, it says if sine of theta is equal to 2/3, find the cosecant of theta. Now, this is actually a pretty simple problem to work out, and you really can get the answer to this without showing any work whatsoever. But let's go ahead and go through the work. Cosecant of theta is equal to 1 over the sine of theta, according to this identity right here. But 1 over the sine of theta is 1 over 2/3 because up here they told us that sine of theta is 2/3. And 1 over 2/3 really means 1 divided by 2/3. And we learn in arithmetic that when you divide by a fraction, that is the same as multiplying by the reciprocal of the fraction. And the reciprocal of 2/3 is 3 over 2. And 1 times 3 over 2 is 3 over 2. So, in the end, you can see that pretty much all we're doing here is we're taking this number and we're just flipping it over. And that's all there is to it for finding the reciprocal. Let's talk about the next set of identities. So next we have what are called the ratio identities, and there are 2 of them. One says the tangent of theta is equal to sine of theta divided by cosine of theta, and the other one says the cotangent of theta equals cosine of theta divided by sine of theta. Let's talk about why these are true. So sine of theta divided by cosine of theta, if we just use the definition, is y divided by r over x divided by r. And this is equal to y divided by r multiplied by the reciprocal of x divided by r, which is r over x. Again, this is just the definition for dividing fractions. And then what happens here is these r's cancel out, and we end up getting y divided by x. But y divided by x is, by definition, tangent of theta. So we've proven that sine of theta over cosine of theta is equal to tangent of theta. And in a similar way, cotangent can be proven to be cosine divided by sine. Let's take a look at an example. So if the sine of theta equals 5 over 13 and the cosine of theta equals negative 12 over 13, find the cotangent of theta. All right, so the solution for this is pretty simple. We know that cotangent of theta, according to the identity above here, is cosine of theta divided by sine of theta. And cosine of theta we know is negative 12 over 13. And sine of theta is 5 over 13. And so once again, dividing fractions, we have negative 12 over 13 multiplied by 13 over 5. The 13's cancel, and this is equal to negative 12 over 5. So again, it's a pretty simple identity to use, at least in this regard. Let's take a look at the next group. So next we have the Pythagorean identities, and these are a little bit more complicated, as you can probably see right away. And the most basic Pythagorean identity is this one right here. And it states the cosine squared of theta plus the sine squared of theta is equal to 1. Now, the rest of these identities can all be derived from this one. So let's make sure we understand this identity really well. Now, first of all, we need to understand some notation. So the notation sine squared of theta, and that's actually how we normally say it, is just a shorthand notation for the sine of theta quantity squared. Okay, so what that means, just to make sure we completely understand this, is if sine of theta is equal to 3/5, then sine squared of theta, by definition, just means sine of theta quantity squared, and that would just be 3/5 quantity squared, which would be 9 over 25 when you square the top and bottom of that fraction. So that's what the expression sine squared of theta means. And that goes for all of the trig functions. So tangent squared means the same thing, cotangent squared, etc. Now let's talk about why this identity is true. So here we have an angle theta in standard position and a point on the terminal side of theta, xy. And we can draw the corresponding triangle. X, Y, and R are the sides of the triangle. And we know from the Pythagorean theorem that x squared plus y squared must be equal to r squared in this picture. That's just the simple Pythagorean theorem. Now, what if I took that equation and divided both sides of the equation by r squared? So what we get is x squared divided by r squared plus y squared divided by r squared is equal to r squared divided by r squared is 1. But then we can further rewrite this. X squared over r squared is the same as x over r quantity squared. Y squared over r squared is y over r quantity squared equals 1. And then from there we can say, but x over r, right? If you look at this picture, theta is an angle in standard position. X over r is cosine of theta. So we have cosine of theta squared plus, and then y over r is sine of theta for the same reason. So sine of theta squared is equal to 1. And then if we just use the convenient notation, we get cosine squared of theta plus sine squared of theta is equal to 1. So you can see that the Pythagorean identity comes directly from the Pythagorean theorem. Now, the other identities can be derived in a similar way. So if you wanted to verify that 1 plus tangent squared is equal to secant squared, or 1 plus cotangent squared is equal to cosecant squared, you could do the same thing. All you would do is you would take the Pythagorean identity, but instead of dividing by r squared to everything, you would just divide by either x squared or y squared. And when you divide by x squared, you would get this identity. And when you divide it by y squared, you would get this identity. So I won't do that here just because the argument is exactly similar to that. But I just thought it would be worth mentioning that you could prove all of those in the same way. Now let's talk about one other thing here. You'll notice off to the side, we have these alternative ways of writing the first identity, right? All of these here come from this one. Now, why is that? Let's have a quick look. So we know that cosine squared of theta plus sine squared of theta is equal to 1. If I wanted to solve for sine squared, I could just subtract cosine squared from both sides. And when I do that, we would get sine squared of theta is equal to 1 minus cosine squared of theta. So that is where this one comes from. Now, in a similar way, I didn't have to subtract cosine squared. I could have subtracted sine squared if I wanted to. And if I would have done that, we would have gotten this one. So those two identities right there come from just subtracting cosine squared or sine squared from both sides of the equation. So those are just alternative formats of the same identity. But then we can actually take it a step further. So if sine squared is equal to 1 minus cosine squared, we can actually take the square root of both sides, and we get the square root of sine squared. That's the absolute value of sine of theta. And that's going to be equal to the square root of 1 minus cosine squared. But then we know that when the absolute value is equal to something, when you remove the absolute value, you get a plus or a minus on the other side. So if we solve for sine of theta, we get sine of theta is equal to plus or minus the square root of 1 minus cosine squared. And that is where this identity comes from. Now, of course, in a similar way, if you took this equation and you took the square root of both sides, you would end up getting this identity. So the bottom line is, all of these extra equations over to the right here, those are just different ways to express this first identity. Now, we'll do some examples in a few minutes to show you how these are useful. But for right now, you should basically understand that all 5 of these are saying exactly the same thing. They're just saying it a little bit differently. Now let's take a look at some examples. All right, we'll start with a couple of review examples. First example says, use the reciprocal identities in the following problems. If cosecant is equal to negative 13 over 12, find the sine. So remember, sine is the reciprocal of cosecant. So if cosecant is negative 13 over 12, sine is going to be 1 over negative 13 over 12. And that's going to be 1 times negative 12 over 13. And of course, that is negative 12 over 13. And again, the quick way to do it is you simply take this fraction here and you're just flipping it over. You're just taking the reciprocal. In the second one, it says if tangent of theta is equal to a, and a is not 0, then find the cotangent of theta. Well, cotangent of theta is 1 divided by tangent of theta. That's the reciprocal identity. But if tangent of theta is equal to a, then cotangent is going to be 1 divided by a. And that's all we can do there. And again, this is okay because they tell us that a is not 0, right? Because we cannot plug 0 in the denominator there. And then we have a couple of examples about using a ratio identity. So in the first one, it says use a ratio identity to find tangent theta if sine theta is 3/5 and cosine theta is negative 4/5. So we'll start with remembering that tangent of theta is sine of theta divided by cosine of theta. That's one of our ratio identities. And sine of theta, they told us, is 3/5. And cosine of theta is negative 4/5. And when you divide fractions, we're going to just simply multiply by the reciprocal. Now, when you do that, of course, the 5's here cancel out. But let's not forget that we still have that negative sign there. Right, so this is like 3 times negative 1, which is negative 3. And then down on the bottom, we have 1 times 4, which is 4. So we get negative 3/4. And likewise, for the second problem, it says find cotangent of theta if sine of theta is 2 over radical 13 and cosine theta is 3 over radical 13. So we say cotangent of theta is cosine theta divided by sine theta. Cosine theta is 3 over square root of 13. Sine of theta is 2 over square root of 13. And by definition of dividing by fractions, we are going to multiply by the reciprocal. And once again, you notice that these cancel out. And so in this one, we end up getting 3 over 2. All right, now let's get into some examples using the Pythagorean identities. So in this first example, it says to find the remaining trigonometric ratios of theta if we know that sine of theta equals 3 over the square root of 10 and theta terminates in quadrant 2. And the key here is we are going to use identities to do this. We are not going to use the definition. All right, so I don't want to use X, Y, and R. I'm going to use the identities that we learned in this section. So if we know sine of theta, we can find cosine of theta because we know that cosine of theta is plus or minus the square root of 1 minus sine squared of theta. So this just comes from the identities that we talked about a few minutes ago. Now, to do this problem, we have to do a couple of things. First of all, we have to choose whether it's positive or negative. It's not both. And then the second thing we have to do is we have to plug in the value for sine of theta. Now, the sine of theta, that's pretty simple. They told us that sine of theta is 3 over the square root of 10, so that's what's going to be plugged in right here. But we still have to choose the positive or negative. Now, here's the thing. We know that theta terminates in quadrant 2. So we have to think about whether cosine is positive or negative in quadrant 2. So we know that all students take calculus. In the second quadrant, the S stands for sine and its reciprocal, which is cosecant. What that means is sine and cosecant are positive in the second quadrant. So if we're looking for cosine of theta in the second quadrant, cosine of theta is going to be negative. So we are going to choose the negative, and then we have the square root of 1 minus sine squared. That's going to be 3 over radical 10 quantity squared. And now we just need to complete the computation here. That's going to be 1 minus, and then when you square 3, you get 9. And when you square radical 10, you get 10. 1 take away 9/10 is 1/10. And this is the square root of 1 over the square root of 10 with a negative sign. And the square root of 1 is 1, so we end up getting negative 1 over the square root of 10. Now that's the key, that's the hard part. Once we know cosine and sine, remember sine was given to us. Once we know these two, we can easily find the rest of the trig ratios. So once we know cosine, secant is the reciprocal of cosine. Well, the reciprocal of negative 1 over radical 10 is negative radical 10 over 1. And then cosecant is the reciprocal of sine, and the reciprocal of 3 over radical 10 is radical 10 over 3. So we can easily get those two. And then the only other ones we need to find are tangent and cotangent. But tangent, remember, is sine divided by cosine. And sine, we know, is 3 over radical 10. And cosine is negative 1 over radical 10. And if you go through the motions here and do your division of fractions, etc., you end up getting tangent is negative 3. And then cotangent, remember, is just the reciprocal of tangent. And the reciprocal of negative 3 is negative 1/3. So we can get all of the trig ratios. Once we have sine and cosine, we can get all the trig ratios very easily. In this next example, we are given that tangent of theta equals negative 3, and theta belongs to quadrant 2. And once again, we want to find the remaining trigonometric ratios of theta. So when you start with tangent, one thing that we can get right away is secant. Now the reason for this is because we know that 1 plus tangent squared of theta is equal to secant squared of theta. And so if tangent is negative 3, we can replace tangent here with negative 3. Now remember that this tangent is also being squared. So this is going to be 1 plus negative 3 squared is equal to secant squared. Now that says 1 plus 9 is secant squared. And 1 plus 9, of course, is 10. And so secant squared of theta equals 10. And if we take the square root of both sides, we end up getting secant of theta is equal to plus or minus the square root of 10. Now, it's not plus or minus. We have to select the right one. So, again, we need to look at the fact that theta is in quadrant 2. And in quadrant 2, we know that sine and cosecant are positive, which means the rest of the trig functions are negative, including secant. So we are going to select the negative sign here. So secant of theta is equal to negative square root of 10. Now, once we have secant, we can very easily get cosine because cosine is the reciprocal of secant. And so if secant is negative radical 10, cosine is going to be 1 over negative radical 10, which is the same as negative 1 over radical 10. And then from there, we can get sine, because remember, we know that tangent of theta is equal to sine of theta divided by cosine of theta. Tangent, we know, is negative 3. Sine of theta is unknown, but cosine of theta is negative 1 over radical 10. And so what we have here is negative 3 is equal to sine of theta, and then when you divide by negative 1 over radical 10, that's the same as multiplying by negative radical 10 over 1. And so what we end up with there is negative 3 equals negative radical 10 times sine of theta. And if we divide both sides by negative radical 10, this cancels out, and we end up getting sine of theta equals 3 over radical 10. And this is because these negatives right here cancel out. Well, once we have sine of theta, we can then get cosecant of theta, because that's simply the reciprocal of sine. So that will be radical 10 over 3. And now I think we have all the trig functions except for one. So we have 4 of them here that you can see. remember in the beginning we were told that tangent of theta is equal to -3. So from that we can get the last trig function, which is cotangent of theta, which is nothing more than the reciprocal of tangent. So that's going to be -1/3. So now we have all 6 of the trig functions. One last example, just to make sure that we have this concept down. So again, we want to find all the remaining trigonometric ratios of theta if cosecant of theta equals -4/3 and theta belongs to quadrant 4. By the way, you might be noticing that I'm using words like trigonometric ratios and trigonometric functions interchangeably. That is because we can basically interchange those. So the trig ratios and trig functions, it's all referring to the same thing. All right, so in this case, we know that cosecant of theta is -4/3. So let's see, the first one that I could find here very easily would be sine, because we know sine is the reciprocal of cosecant. So that would be -3/4. So that's one down. Now, once we know sine, we can get cosine. So let's remember that cosine squared theta plus sine squared theta is equal to 1. And I'll take a slightly different approach than I did a couple of examples ago. I'm going to plug sine of theta equals -3/4 into here. That's going to give us cosine squared plus -3/4 squared is equal to 1. This is cosine squared plus 9/16 is equal to 1. And then we can subtract 9/16 from both sides. And this will give us cosine squared of theta equals 1 minus 9/16. So we need to remember that 9/16, if you take that away from 1, that's going to be 16/16 minus 9/16, right? Because 1 is the same as 16/16. That's going to be 7/16. And then we'll take the square root of both sides. And that gives us cosine of theta equals plus or minus the square root of 7/4, right? Because the square root of 16 is 4. But again, it's not plus or minus. We have to choose positive or negative, and we have to choose correctly. Theta, in this case, is in quadrant 4. Cosine in the 4th quadrant is positive. So we're going to select the positive sign here. So cosine of theta is equal to radical 7/4. All right, so now we have sine, we have cosine. Let's go ahead and get secant. Secant is the reciprocal of cosine, so that would just be 4/radical 7. And the only other two we need to get are tangent and cotangent. Tangent, we know, is sine divided by cosine. Sine is -3/4 divided by cosine is radical 7/4. And when you invert and multiply, etc., as we have been doing, we end up getting -3/radical 7. Okay, so this is tangent of theta. And then finally, we can get cotangent of theta by simply taking the reciprocal of that, which will be -radical 7/3. All right, so what we want to do is we just want to get comfortable with not only memorizing these identities, but being comfortable using them to do problems.